Hello, my dear students. Last class, I explained about beams and different types of beams. Okay, today we will focus on the main types of beams. That is, I have mentioned yesterday's class: cantilever beam, simply supported beam, overhanging beam, fixed beams, and continuous beams. Okay, this how they look. Cantilever beam looks like. Simply supported beam is like this. Overhanging, and this is continuous, this is fixed ended, and this is cantilever or simply supported. This we don't in your syllabus, it is not there. Okay, then we will see what is cantilever beam. Okay, cantilever beam is fixed at one end and free at the other end. Okay, see here, you can see it is fixed at one end and free at the other end. This is the length of the beam and load is acting at the free end. See, these are some of the examples. You can see here, cantilever, one end is fixed, and other end is free. Okay, and here see, one end is fixed and other end is free. Okay, next is simply supported beam. Simply supported beam is the beam which rests freely on the supports at its two ends. Okay, you can see here, these are the two supports. It rests on the two supports. Okay, this is the length of the beam. You can see here, this also support is there, this side also support is there. Okay, it resting freely on both the ends, supports. Okay, then fixed beam. What is this fixed beam? If both ends of the beam are fixed or built in walls, then it is called as a fixed beam. It is also called as built-in beam. See here, both the ends are fixed. Okay, you can see here, this also fixed, this side also fixed, this side also fixed, this side also fixed. Both the ends are fixed. See here, you can see both the ends are fixed. Okay, next is overhanging beam. If the end portion of the beam is extended beyond the support, then it is called overhanging beam. It is extended outside the supports. You can see here, this is one support, this is one support. It is extended beyond the support. Again, there are two types, single-sided and double-sided. Here now only one side it is extended. It may extend this side also, then it is called as double side overhanging beam. Okay, can see here. Example, see here, this is support, it is extending beyond the support. Okay, see, you can see here, this is extended beyond the support. Okay, here this is example for both the sides, it is extended beyond the support, both the supports. Okay, then continuous beam, a beam which is provided with more than two supports, then it is called as continuous beams. Here there are more than two supports. Okay, see here, you can see this is one support, this is one support, and this is also fixed support, simply support, and this is roller support, and again here it is fixed support, more than the two supports. You can see here, this is the continuous beam. Here beams are more than supports are more than two. Okay, then one more important thing, this also you should know, what is statically determinate beam and what is statically indeterminate beam. Okay, statically determinate beam means in this type of beams, all the reaction components can be calculated by applying the three conditions of static equilibrium. Okay, if the number of the reaction that can be calculated by using only the conditions of the equilibrium. What are those conditions of equilibrium? That is, summation of vertical forces equal to 0, means the algebraic sum of all the vertical forces is equal to 0. Then summation of horizontal forces equal to 0, means the algebraic sum of all the horizontal forces, that is equal to 0. Then sigma m is equal to 0, that is the summation of all the moments is equal to 0. If you could able to calculate the reaction component by using only the conditions of equilibrium, then you can say it is statically determinate beam. Okay, for example, simply supported beam. Okay, now let us take one simply supported beam. How many ends here in suppose I'll consider one simply supported beam. Okay, this is one simply supported beam. How many reactions here? This is suppose roller support. Okay, only one reaction here. Okay, VA or RA, and this side also VB or RB. Okay, how many reactions now here? Two. This is one and this is at B. Okay, two reactions. How many conditions of equilibrium? Three. So it is less than 3, 2. So you can find the reaction component by using the conditions of equilibrium. Okay, because number of the equilibrium condition is 3 and reactions are 2. So this is less than the conditions of the equilibrium. So this type of beam, simply supported beam, is an example for statically determinate beam. Even cantilever, that is also example for this beam, because see now here this is one end is fixed and other end is free. How many reactions here? There is horizontal, there is vertical, and there is moment also, right? So three. So conditions, if the number of the reaction component is less than or equal to 3, then you can say it is determinate beam. So this is less than, or this is not less than, this is equal to the conditions of equilibrium. So you can say that it is statically determinate beam. Okay, then we'll see what is statically indeterminate beam. What is statically indeterminate beam? In this type of beams, the number of the unknown reaction components, okay, the number of unknown reaction components exceeds the static equilibrium conditions. Means if the number of the reaction component is more than the conditions of the equilibrium, then it is called as statically indeterminate beam. For example, this fixed beam. Okay, why fixed beam? See, let us consider one, let us consider here one fixed beam. Okay, this is one fixed beam here. Okay, how many reactions here? Here 3 and here 3. So total it becomes 6, right? So it is more than the condition of the equilibrium. So you cannot find the reactions by using only the conditions of equilibrium. So this beam is a good example for statically indeterminate beams. And also this continuous beam also we can say. For example, this continuous beam here, this is one end is fixed and this is simply supported, and this also suppose this also fixed end. Okay, then if number of the supports are more than 2 continuous beam. So here number of the reactions, this side 3 plus 1 4 plus 1 plus 3 7. So it is more than the conditions of the equilibrium. So you cannot find the reaction components by using only the conditions of the equilibrium. So this is called statically indeterminate beam. This is very important. Okay, you should able to recognize whether it is statically determinate or indeterminate beams. In this you're studying mostly the most problems on statically determinate beams only. Okay, now next semester you're going to study the indeterminate beams. Okay, then what are the different types of the loads? This already you know. I'll just brush a few. What is this concentrated load, right? What is this concentrated load? It is a point load. This type of load acts relatively on a smaller area. Okay, it is very small. It's acting on very smaller area. For example, force exerted by a chair or a table leg on the supporting floor. You imagine one floor and the load exerted by the chair or a table. It is very less compared to very less area. Okay, so that is concentrated load. And what is uniformly distributed load? That is also represented by the symbol UDL. As the name itself implies, uniformly distributed load is spread over a larger area. Its magnitude is designated by its intensity, Newton per meter or kilonewton per meter. Okay, here for example, the water pressure on the bottom slab of the water. You just imagine, okay, the water pressure on the bottom slab of the water tank is an example for a uniformly distributed load. Okay, and also if a floor slab is supported by the beams, The load of the slab on the beam is certainly a uniformly distributed load. Okay. Here, main thing you have to see that self weight of the beam itself is uniformly distributed. Okay. For convenience, uniformly distributed load is always converted into its equivalent concentrated load. Okay. Acting at the center of gravity of the load. So this I will explain in detail while solving the problem. Then what is this uniformly varying load? UVL. This type of load will be uniformly varying from zero intensity at one end to designated intensity at the other end. See here, this is 0 and there is some intensity here. So it is varying from 0 intensity at one end to the designated intensity at the other end. Okay. For example, a triangular block of a brickwork partially imposes a loading on a beam. Okay, for example, and also the water pressure distribution on the walls of the water tank could be another example. Okay. And again here also the equivalent concentrated load, you have to convert into equivalent concentrated load. That is means you have to convert into load. How you can convert into load? Half into base into height. Okay, that load is equal to area of the triangle. Then one more type also there that I have not mentioned, concentrated moment. Moment also a one of the type of the load. So beam is to accommodate a load on the bracket mounted on it. So what it gets transmitted on the beam is a concentrated moment. Okay. So this is a uniformly distributed load. Here you can see this is a point load. Okay, I have mentioned here this is moment, or it is also called as a couple. Okay, so point loads are like this, concentrated loads acting at a point, and uniform load distribution over wide area, rate of loading per unit length, W per unit length, and uniformly varying load, triangular distributed load. Okay, here like this, intensity of the load at one point to that at the other, and then couple you can see here. Okay. Then what the loads do? See, the loads or the reactions bend the beam and try to shear through it. So when you apply the load, you just imagine there is one beam. What happens? The beam bends, or it may be shear off like this. Okay. That is the load, what the loads do. And also you can see how it bends. See here, it bends like this. So the stopper surface, this top surface, it gets compressed. So here there is compression, and here it is elongated, therefore it is tensile force. And shear, what happens? It divided into the two blocks. Okay. And next we will see what is shear force and bending moment. Okay, what is shear force? Shear force at the cross section of a beam may be defined as the unbalanced vertical force to the right or left of the section. Okay, this is the means it is an unbalanced vertical force to the right or left of the section. Then what is bending moment? The bending moment at the cross section of the beam may be defined as the algebraic sum of the moments of the forces to the right or left of the section. This is the algebraic sum of all the moments of the forces to the right or left of the section. Okay, so this is very important. Now actually I came to the point what is shear force and bending moment. Okay, while calculating the shear force or bending moment at a section, the end reactions must also be considered along with the other external loads. Means you have to consider the reactions also. So in next class I will go in detail what is shear force diagram, what is bending moment diagram, what are the sign conventions, and how the shear force diagram and then bending moment diagram for cantilever beams and simply supported beams. Hope all of you understood. If you have any difficulties or doubts, we'll discuss in the class. Thank you.